James, Ashley, algebra. I've done this with James a few times now, but I think good that Ashley, if you can understand some of this, then maybe you can work through it together. I never give this session the same way twice. It's kind of something that's built up over a long time, and this is one lesson which has got less structure and more of the kind of a stream of consciousness. So I'll just carry on and we'll see how we go. Okay, when we say that A is equal to B, this symbol equals means absolutely identical to. It's the same thing, there's no difference, they are the same thing on both sides of on the left hand side and the right hand side. They're equal or equivalents, and the basic logic is that you can do equivalent things to identical items, and the statement remains true. The kind of things you might do is, for example, multiply both sides by 3 or add 7 to both sides. So you've got, say you've got 5 is equal to 5, then 5 times 3 is equal to 5 times 3, or 5 plus 7 is equal to 5 plus 7. Quite often we don't have numbers, we just have, say, x minus 3 is equal to 8, say, and we can do something like, say, add 3 to both sides. X take 3 add 3 is equal to 8 add 3. So happens I've chosen it so that minus 3 plus 3 unwrap each other, so we get x on its own, and 8 plus 3 is 11. The idea of inverses or opposites comes into play. Very simply, if you want to unwrap a plus, the opposite of plus is minus, and vice versa. So the opposite of minus is adding. The opposite of multiplying is dividing, and the opposite of dividing is multiplying. The opposite of squaring is square rooting. The opposite of square rooting is squaring. They're known as inverse operations. You need to know inverse operations so that you can rearrange or solve algebraic equations. To do that, first of all, there's a certain grammar or syntax or order that goes when you make a piece of algebra. Say, for example, 3a plus b is equal to 7. Okay, and let's look at the letter A in this sentence. You can think of it as a sentence. There's a certain order that things happen to it. The first thing that happens to it is it gets multiplied by 3, and the second thing that happens to it is that you add b to it. You can think of this as something like 3 times 4 plus 1, for example. Now there's an order to this. The first thing that you work out here is 3 times 4, 12, and then you add 1 to it, giving you 13. Now when you do algebra, one thing is that instead of, we usually omit the multiplication sign. So you have AB means, or is equivalent to, A times B. But we usually just don't write the multiplication sign. Also, as a convention, we don't write 3ACB is equal to 9. We write algebraic expressions with a number first and then the letters in alphabetical order. So by convention you wouldn't write A3CB, you write 3ABC is equal to 9. I'm not a big fan of mnemonics, which are fancy word, which means, James, a mnemonic is a word which helps you to remember something. You already know some of this because you've done a lot of these simple rearrangements. BODMAS generally is an order. We deal with brackets first, multiplication and division second, and finally adding and subtracting third. So for example, 3 open bracket 2 plus 2 add 1, for example, in numbers. The first thing you simplify here is the 2 plus 2, which gives you 4, so we get 3 times 4. Remember, there's no multiplication sign there, so it just means it's multiplied. We can put it in as a multiplication, plus 1. And then we've dealt with the brackets. Now we deal with the division multiplication, so we work out the 3 times 4 part, 12 plus 1, and then combine it with the addition and subtraction, 13. Generally when you write equal signs they should be above each other in a column, and underline the answer twice is a sort of convention as well. Now the reason I'm just choosing numbers here is because the way that numbers are structured is the same way that letters are structured in algebra. For example, 2x minus 1 is equal to 5. So there's a definite order here. If we're looking at x, considering x, the first thing that happens to x is that it's multiplied by 2, so that's the first operation. And then the second thing that happens to the x, second thing that happens to this whole lump here, 2x, is you take away 1 from it, and that's identical to 5. So again, this side, the left hand side, is absolutely identical to the right hand side. And what we're looking to do is unwrap this equation so that we get an x on its own. We make x the subject, that's the terminology, and what that means is x is equal to a lump of algebra or numbers that doesn't involve an x. When we have numbers in it, we call this solving an equation. So if I just cover up the plus 5 here, this part here is referred to as an expression. In fact, it's called an expression in x. Other words that we use to talk about algebra, the coefficient of x is 2. So the coefficient of a number is, or the coefficient of a entity, so to speak, or an object, is the thing that multiplies it. So the coefficient of x is 2. A term is anything separated by a plus or a minus or an equals sign. So there's one term here, one term here, one term here. This is called an expression. When you have an equal sign, the whole thing is referred to as an equation. I went through that pretty quickly, so I'll just do some more. AP plus Q is equal to R, say. So we can say that the coefficient, which means the thing that multiplies P, is A. This is a term in AP, this is a term in Q, and this is a term in R, and that would be known as the constant term. So a number on its own is called a constant. This is, I mean, the terminology is something which probably James won't be meeting too heavily, but it's good to know it, you know, just so we can talk about the bits of an equation. Now, to solve this equation, what we need to do is identify the order that things happen to x. X, first of all, is multiplied by 2, and then we take away 1 from it. You can think of that, if you're never sure, kind of a trick that I learned was just to think of some very simple numerical example, 2 times 3 plus 1, which is kind of similar to what we've got written here. It's the same structure. We can say, see, this 3 is the x. The first thing, double it and add 1 to it. Now, James has done a lot of these and understands this concept. What we're trying to do then is we're going to unwrap or apply inverses or cancel out or vaporize or undo the operations, meaning adding, subtracting, timesing, dividing, in reverse order that they were kind of put onto the x. You can keep on applying operations to x. You know, this happens to have 2 steps. You can do 3 steps, 4 steps, 5 steps. As long as you can read the sentence properly, then you can unwrap really complicated looking algebra. And when I say unwrap, I mean solve. So I have to keep these to 10 minutes to post to YouTube, so I will stop it here and carry on in a sec.